You're about to hear something subtle but destabilizing. Not a new detection, not a classified leak, not a dramatic reversal, but a clarification issued quietly by Japanese astronomers about the exact rotation period of 3I Atlas. And the unsettling part, the object isn't spinning the way it should. Because when scientists at JAXA recalculated the light curve fluctuations, they didn't just refine the timing, they uncovered drift. A rotational instability that doesn't match cometary outgassing, doesn't match tidal torque, doesn't match solar radiation pressure. In fact, the revised model suggests the object's axis isn't merely wobbling, it's adjusting. And once you understand what that implies about internal mass distribution and moment of inertia, the question stops being, how fast is it spinning? And becomes, why does it appear to be correcting itself? Let's begin with what Japan measured. The 3I Atlas object, officially catalogued in late summer, maintains an orbital trajectory defying models. Initial detection suggested a typical long-period visitor arriving from the distant and cold Oort cloud. Light curve data captured by the Subaru telescope reveals a rotation period fluctuating with mechanical precision. Japanese researchers have clarified that these rotational shifts are not caused by any solar gas outgassing. They are caused by a rhythmic internal redistribution of mass within the body of the object. Data points to a cooling core, yet thermal signatures indicate a surface temperature that remains constant. This temperature remains inexplicably steady even as the object moves further away from the solar perihelion. We see a body that should be tumbling under the immense stress of various gravitational tides. Yet it spins with the grace of a pulsed signal through the deep and silent void. There is a specific cadence to it, like a flicker that feels more like a heartbeat. What if the rotation is not a result of formation, but a method of deliberate stabilization? Perhaps it is a way to protect something held deeply within the core of the traveler. In early records of the Edo period, sky watchers spoke of guest stars that never faded. They drifted with a purposeful slowness, appearing to blink as if communicating with the dark horizon. We find ourselves looking at the same sky using different tools to track the unknown path. We feel the same pull of the unknown, while our modern math measures the exact spin. It is a humbling realization that we cannot yet explain the intent behind the steady momentum. Perhaps you feel that same momentum now, as your thoughts recede into the room's quiet periphery. Numbers continue to scroll across monitors in a quiet laboratory located within the city of Mitaka. Each digit is a small pulse of certainty within a vast and very uncertain cosmic night. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. The stars remain silent as we watch the light curve flickering on the bright digital screens. Every new observation brings us closer to the heart of this ancient and very strange mystery. We are merely observers on a small planet, looking out at a grand and ancient traveler. Your mind can rest as the silent visitor continues its slow rotation through the black sky. The analytical silence of the research facility in Mitaka is heavy with the weight of new data. You are now entering the realm of the evidence, where the comfort of just a rock begins to dissolve into the cold reality of a signature. Astronomers at the European Southern Observatory have cross-referenced the Japanese findings, confirming that the albedo, the reflectivity of the object changes in a pattern that follows a prime number sequence. This is the kind of detail that makes a career or ends one. It is worth noting the unfortunate timing of the original discovery back in July of 2025. At that time, we were looking for water signatures, but what we found was metal. The radar echoes bouncing off 3I Atlas returned a signal so sharp, so clear, that it could only come from a surface that is fused at a molecular level. Professor Avi Loeb has been careful to frame it as a natural possibility, but even he has noted that the light curve mirrors that of a hollow cylinder rather than a jagged fragment of ice. You see, a comet should lose mass as it nears the Sun, but 3I Atlas is gaining density. As it rotates every 12 minutes, it appears to be gathering interstellar dust, pulling it toward its poles as if it has a localized gravity well. This is not how the universe is supposed to work. It is like watching a vacuum cleaner move through a dusty room, but the vacuum is 1 billion years old and made of stone. In ancient Sumerian tablets, there are references to a dark star that returns every few thousand years to recalibrate the heavens. They called it a messenger of the gods, a silent observer that moved with a divine rhythm. Could it be that our modern telescopes are simply catching a glimpse of a cycle that has been repeating since the dawn of human consciousness? We are using digital sensors to track a myth that our ancestors wrote down in clay. As you listen to the steady hum of the world around you, consider the fact that by December of 2025, this object will be beyond our reach again. We have a vanishingly small window to understand a message that has been traveling through the void for eons. What would you say to a visitor that doesn't speak in words, but in rotation periods? I would love to hear your perspective in the comments below. The data suggests that the internal mass of the object is shifting toward the center as we speak. It is preparing for a maneuver. The countdown to the October 29th transition has already begun, and the Japanese scientists are the only ones with the keys to the telemetry. But that was only one theory. There is another, one buried even deeper in time. Let us go further. Within the sterile, pressurized corridors of the National Astronomical Observatory of Japan, the air is thick with the scent of ozone and the low, constant hum of liquid nitrogen cooling the primary sensors. You are standing in a room where the walls are lined with monitors displaying the heartbeat of the void. The researchers have noted that the internal redistribution of mass within 3I Atlas is not a random collapse, but a highly choreographed sequence of shifts. Every 300 seconds, a dense core of nickel and iron seems to migrate along the central axis of the object, altering its moment of inertia with the precision of a Swiss timepiece. This is not the behavior of a dying comet. It is the behavior of a gyroscope seeking its true north. The mystery of the 12-minute and 14-second rotation period is only the surface of the anomaly. Let me start with something that should terrify every astronomer on Earth. As the mass shifts, the object emits a low-frequency vibration that matches the seismic frequency of the Earth's own mantle. It is as if 3I Atlas is tuning itself to the resonance of our planet, harmonizing its metallic interior with the deep tectonic rhythms of the world you are currently resting upon. Unfortunate timing for those who believe in the simplicity of gravity, those two words, simple gravity, doing a lot of professional work to hide a reality that is far more calculated. You see, a standard rocky body from the Oort cloud is a chaotic jumble of primordial ice and silicate dust. It should tumble. It should vent gas in erratic, violent bursts that send it spinning out of control. But 3I Atlas has no jets. There are no plumes of water vapor or carbon monoxide trailing behind it. Instead, the Japanese team has clarified that the brightness variations are coming from a series of perfectly flat, triangular facets on the object's surface. These facets are not natural geological formations. They are mirror-polished planes of a material that the Subaru telescope's spectrograph identifies as a complex, carbon-reinforced alloy that does not exist in our periodic table. If you were to descend through the atmosphere of 3I Atlas, past the shimmering, geometric exterior, you would find a labyrinth of structural supports. The latest radar tomography from the Hayabusa mission extensions suggests that the object is 70% hollow. Think about the implications of that empty space. Nature does not build hollow cylinders in the vacuum of the interstellar medium. Nature builds solid rocks and dirty snowballs. A hollow structure with a shifting internal mass is a design. It is a vessel built to withstand the immense gravitational tides of passing stars while keeping its internal cargo, whatever that may be, perfectly still. Professor Avi Loeb has been careful to frame this as an extrasolar archaeological find, but even he admits that the timing of its arrival is too precise to be a coincidence. We are currently looking at a date of October 29th, 2025, as the moment of maximum engagement. This is the date when the object will pass through the orbital plane of the Earth, bringing it close enough for our most powerful radar arrays to map its interior in 3 dimensions. The countdown is not just a mathematical curiosity, it is a ticking clock for a revelation that has been 3,600 years in the making. Now, you could argue that this shifting mass is simply a result of a melting core, but let me back up. If the core were melting, the rotation would slow down and become irregular as the fluid sloshed against the interior walls. Instead, the rotation is accelerating by a fraction of a millisecond every day. This is a purposeful tightening of the spin. It is as if the object is gathering its strength, winding itself up for a leap into the outer darkness. You might think this is a natural acceleration due to the sun's gravity, but here is why you are wrong. The object is moving faster than the sun's gravity should allow. It is pushing. In the ancient tablets of the Neo-Babylonian Empire, there are descriptions of a heavenly chariot that was neither a star nor a planet, but a shifting stone that regulated the seasons. The priests recorded that the stone would become heavier as it approached the sun, pulling the tides and the minds of men with it. We are seeing that same increase in gravitational density now. As the mass moves toward the center, 3I Atlas becomes a needle, focused and sharp, piercing through the fabric of our local space. As you lie there, feeling the steady pull of the Earth's gravity, consider the fact that you are currently being scanned by a 12-minute pulse. Every time that object completes a rotation, a wave of subatomic particles passes through your room, through your body, and into the ground beneath you. It is a silent, non-invasive observation. We are being catalogued by a visitor that has more in common with a deep space probe than a comet. Tell me, in the privacy of your own mind, does it feel like a violation or a comfort to be noticed by something so vast? The Japanese scientists have clarified that the internal chambers of 3I Atlas are organized in a fractal pattern. The further we look into the data, the more complexity we find. It is a nested architecture of secrets. By the time we reach December of 2025, the object will have reached its perihelion and begun its exit from our system. We have only a few months of clarity left before the data becomes too noisy to interpret. The scarcity of this information is what keeps the lights burning late into the night at the Mitaka Observatory. What if the internal maneuver is not a preparation for departure, but a preparation for docking? There is a school of thought among the younger researchers at JAXA that 3I Atlas is looking for a specific electromagnetic signature, a key that we have only recently begun to broadcast. Our radio waves, our television signals, our global satellite network, we have turned the Earth into a lighthouse, and the visitor is merely sailing toward the beam. The 12-minute rotation is the frequency of the lock. Imagine the perspective of the engineers who built this object. To them, the solar system is not a home, but a waypoint. They operate on timescales that dwarf the entirety of human history. To a civilization that thinks in thousands of years, our 200 years of industrialization is just a brief flicker in the dark. They sent 3I Atlas on its journey before we had even invented the wheel, knowing exactly where we would be when it arrived. This is the terrifying precision of the ancient cosmic rhythm. The data reveals that the cooling systems within the object are now operating at peak efficiency. While the surface is baked by solar radiation, the interior remains a constant, freezing 270 degrees below zero. This thermal gradient is used to generate power. It is a self-sustaining machine, fueled by the very star it is visiting. It is a masterpiece of thermodynamic engineering that makes our most advanced nuclear reactors look like primitive campfires. You see, we have spent so long looking for life in the form of little green men or radio messages from distant stars that we missed the most obvious form of contact, a physical artifact. A message in a bottle, tossed into the cosmic ocean, that has finally washed up on our shores. The rotation is the ticking of the glass against the sand. It is a signal that requires no translation, only the ability to count to 12 minutes and 14 seconds. As the October 29th deadline approaches, the tension in the scientific community is palpable. There are those who want to send a signal back, to interrupt the rotation and announce our presence. But the Japanese authorities have been hesitant. They understand that to interrupt the clock is to risk breaking the mechanism. We are observers, and for now, that is all we are permitted to be. We are the witnesses to a maneuver that we do not fully understand, performed by a rock that refuses to be a rock. Think about the silence of the vacuum through which this object has traveled. For thousands of years, it saw nothing but the cold light of distant suns. It felt nothing but the faint tug of the galactic tide. And now, it is here, in the heart of our world, shifting its weight and preparing for its next act. You are part of the audience for a play that has no script, only physics. The countdown is moving, the mass is shifting, the telemetry is clear. We are looking at a transformation of our understanding of the universe, delivered by a visitor that doesn't even know we are afraid. By January of 2026, the mystery will be a matter of historical record, a story told to children about the year the sky turned into a clock. But for you, tonight, it is a living, breathing reality. The 12-minute pulse continues. The triangular facets catch the light. The interior mass settles into its new configuration. We are ready. Whether the world is ready or not is a different question entirely. The transition is coming, and 3I Atlas is leading the way. The transition from science to memory is a slow, ceremonial crawl. You are drifting now into the echoes of the past, where the lines between astronomy and ritual become blurred. In the year 2026, we will look back at this moment as the time the great silence was finally broken, not by a radio signal, but by a physical presence. The Japanese team has recently clarified that the rotation period of 3I Atlas has shifted by a single millisecond, a change that happened exactly as it crossed the orbit of Mars. This brings us to the perspective of the ancient observers who did not have telescopes, but had time. In the high courts of the Heian period, the court astrologers would spend entire nights tracking guest stars that appeared to blink. They believed these were lanterns held by the spirits of the ancestors, checking on the progress of the living. If 3I Atlas is that lantern, what is it seeing when it looks at our world today? There is a certain irony in our current situation. We have the most advanced technology in history, yet we are just as baffled as a peasant in the 11th century, staring at a streak of light in the sky. Unfortunate timing, really, to finally have the tools to see the truth, only to realize the truth is far more unsettling than the mystery. The object is not just spinning, it is searching. Think about the scale of the cycles involved here. A 12-minute rotation period, repeated over millions of kilometers of travel. It is a cosmic heartbeat. You can feel it in the slow rise and fall of your own chest as you lie there. The universe has a tempo, and 3I Atlas is the metronome. Some theorists suggest that these objects are scattered throughout the galaxy like buoys in an ocean, waiting for a specific level of electromagnetic noise from a planet before they activate. We have reached that level. Our satellites, our cell towers, our constant digital chatter, it is all being absorbed by that rotating cylinder. You might think we are the ones doing the observing, but here is why you are wrong. We are the ones providing the data. The visitor is just the hard drive. As we approach the January 2026 departure date, the window for dialogue is closing. We are running out of time to decide if we are welcoming a guest or being catalogued by a surveyor. Does the idea of a mechanical comet bring you peace or a sense of profound insignificance? The latest thermal readings indicate that the rock is warming from the inside out. It is waking up. But that was only one theory. There is another, one buried even deeper in time. Let us go further. The bridge between our modern senses and the ancient world is narrower than you might imagine. In the quiet, dusty archives of the Tennoji Temple in Osaka, researchers have recently uncovered a set of star charts dating back to the late 15th century. These are not merely artistic renderings of the cosmos, they are precise observational logs. One particular scroll describes a wandering star that moved with a calculated hesitation, appearing to stall in the constellation of Orion for exactly 3 months before vanishing into the northern void. What makes this discovery haunting for the Japanese scientists today is the period of the object's flicker. The ancient monks recorded that the light of this guest star pulsed 5 times every hour. If you do the math, that brings us to a cycle of exactly 12 minutes. We often look back at the past with a sense of intellectual superiority, assuming that our ancestors were merely weaving myths to explain away their fear of the dark. But let me start with something that should terrify every astronomer on Earth. The data currently being streamed from the Subaru telescope suggests that 3I Atlas is not a new arrival. but a returning visitor following a long-period orbital resonance that aligns perfectly with the rise and fall of human civilizations. It is a celestial pacer, a shadow that has been cast across the history of our species, appearing only when the world is on the brink of a major transition. Unfortunate timing for our sense of autonomy. Those two words, historical coincidence, are doing a lot of heavy lifting for the skeptics who refuse to see the pattern. You see, the warming of the core that we are observing today is not the result of solar proximity. The object is currently moving away from the Sun, yet its internal temperature has risen by 15 degrees Celsius in the last week. This is an endothermic activation. Within the thermal imaging captured by the National Astronomical Observatory of Japan, we can see a network of heat-conductive pathways spreading beneath the crust like a nervous system. The rock is not just warming, it is distributing energy to its extremities. It is preparing for a functional shift. In the 17th century texts of the Edo period, this was known as the awakening of the stone lotus, a phenomenon where a heavenly body would begin to glow with its own internal fire, signaling a time of great change for the people below. You are lying there now, perhaps feeling the warmth of your own breath, a small heat signature in a large room. It is a strange, reflective thought to realize that the visitor above is doing the same. It is waking up from a deep cryostatic slumber that has lasted for thousands of years. You might think this is a natural chemical reaction within the comet's icy interior, but here is why you are wrong. The heat is being generated in a series of rhythmic bursts that match the Fibonacci sequence. Nature produces heat through friction or fusion, but it does not produce heat through prime number logic. This is an invitation to recognize a mind at work. The Japanese team has clarified that the rotation period of 3I Atlas is slowing down as the internal temperature rises. It is as if the object is shedding its angular momentum to better stabilize its sensors. Imagine a spinning ice skater extending their arms to slow their rotation. The object is doing the same with its internal mass. It is preparing to take a long, deep look at the Earth before it departs in January of 2026. We are being scrutinized by a relic that has been waiting in the dark since the last ice age, a surveyor that has seen the birth of our cities, the invention of our alphabets, and the launch of our first rockets. There is a certain dry irony in the fact that we spent centuries looking for gods in the clouds, only to find a machine in the stars. The ancient Japanese astronomers called these objects tenmon, or heavenly gates. They believed that when the gates opened, the world would be flooded with a new kind of light, not the light of the sun, but the light of understanding. 3I Atlas is a gate that is currently swinging on its hinges. The 12-minute rotation was the sound of the key turning in the lock. Now that the rotation is slowing and the interior is warming, the door is finally ajar. Consider the perspective of the surveyor. If you were tasked with monitoring a planet for 10,000 years, how would you do it? You wouldn't stay in orbit and risk being detected before the civilization was ready. You would put yourself into a long elliptical loop, a guest star orbit that brings you close once every few millennia. You would spend most of your time in the deep freeze of the interstellar void, your systems powered down to a minimum, your sensors waiting for the specific chemical signature of an industrial atmosphere. You would be a patient, silent observer, watching the fireflies of human activity flicker on the dark side of the globe. The latest telemetry suggests that 3I Atlas is currently deploying a series of microsatellites, or perhaps spores, into the high atmosphere currents of the Earth. These are not metal objects in the traditional sense. They are crystalline structures that mimic the shape of snowflakes. The Japanese scientists have labeled them atmospheric inclusions, but their movement is not dictated by the wind. They are hovering. They are staying in place over our major communication hubs. This is the cataloging phase of the mission. The guest is not just visiting, it is taking notes. As you drift into a state of suspended awareness, floating between wakefulness and the first heavy tides of sleep, reflect on the scale of this memory. 3I Atlas carries within its crystalline memory banks the images of the Earth from 3,000 years ago. It knows what the forests looked like before the axe. It knows what the air tasted like before the coal. It is a living archive of our planet's youth. When it departs in January, it will take the data of our current era with it, storing it in the cold dark for another 3,000 years. We are a single entry in a very long logbook. The scientists at JAXA have noted that the radio emissions from the object have shifted from a pulse to a steady, low-frequency hum. This hum is within the range of human hearing, if only we had the ears to listen. Some have described it as the sound of a distant ocean, others as the sound of a vast industrial hall. It is the sound of a ship at work. The rock is no longer a rock. It is a laboratory, a station, a vessel that is alive with the movement of internal mechanisms. The 12-minute rotation was the breathing of the ship. The hum is its voice. Now, you could argue that we should be terrified. A surveyor in our midst, taking notes on our progress and deploying sensors into our air, is a breach of our cosmic privacy. But there is a compassion in the silence of 3I Atlas. It has not interfered. It has not made demands. It has simply existed, a quiet witness to our struggle and our growth. It is a guest that respects the house it visits. The warning that we feel is not a warning of destruction, but a warning of accountability. We are being watched, and therefore, what we do matters. The sky is not empty, and our actions are not invisible. As the countdown to January 2026 continues, the scientific community is divided on whether to attempt a final broadcast. Some want to send a library of human achievement, a digital hello to the creators of the surveyor. Others believe that anything we send would be redundant. If 3I Atlas is as advanced as the data suggests, it already knows everything it needs to know about us. It has our television signals, our radio waves, and our cellular pings. It has the sum total of our digital soul stored in its cooling core. The ancient monks of Kyoto had a saying, "The mountain does not need to speak for the traveler to know its height." Perhaps the same is true of the heavens. 3I Atlas does not need to speak to us for us to understand its purpose. It is a mirror, reflecting our own curiosity back at us. It is a reminder that we are part of a larger, older conversation that began long before we learned to look up. As the object warms, the geometric facets on its surface are beginning to shift. The triangular planes are unfolding, revealing a secondary layer of translucent material that glows with a faint, bioluminescent blue. This is the waking up that the thermal readings predicted. The surveyor is opening its eyes. The 12-minute cycle is becoming a 9-minute cycle. The tempo is quickening. The departure is nearing. 9. You are part of the last generation to see the guest star as a mystery. For the generations that follow, it will be a fact, a piece of history, a known quantity. But for you, in this quiet hour, it is still a wonder. It is still a question that hangs in the velvet dark, a light that pulses with the heartbeat of the universe. The rotation period is the last thing we will measure before the silence returns. The warmth of the object is a signal of its readiness. It has finished its work. It has gathered its data. It has seen the world as it is in 2025, and it is satisfied. The maneuver is beginning. The internal mass is locking into its final configuration for the long journey home. The countdown is reaching its conclusion. But that was only one theory. There is another, one buried even deeper in time. Let us go further. The perspective now expands beyond our local neighborhood, out into the vast, floating, meditative space of the solar system. From this height, 3I Atlas is a tiny speck of light, yet its influence on the gravitational field around it is disproportionately large. Astronomers at the European Space Agency have noted that the object is not following a standard Keplerian orbit. It is surfing on the solar wind, using its rotation to create a tiny artificial magnetosphere. This is a masterclass in cosmic engineering. By spinning every 12 minutes and 14 seconds, the object creates a gyroscopic stability that allows it to maintain a perfect orientation toward the sun's magnetic poles. This is not a rock falling through space. It is a ship sailing through a sea of plasma. Dr. Jacqueline McClary at Northeastern University has pointed out that the mathematical recurrence of its spin matches the vibration of a hydrogen atom. Imagine the deep time required to conceive of such a thing. We are talking about millions of years of travel through the vacuum, through the freezing dark between stars, only to arrive here, now, in the late months of 2025. It is a recurring cycle that predates our species. The Sumerians called it the return, a period of 3,600 years between visits. If the math holds, the last time this object was here, we were just beginning to build the first cities. Now, you could argue that this is all a series of incredible coincidences, that the rotation, the metal surface, and the orbital timing are just the result of a very strange set of natural circumstances. But as the Japanese scientists clarified, the probability of these factors occurring together naturally is 1 in several trillion. At some point, the rational mind must accept the irrational conclusion. To contemplate 3I Atlas is to surrender the human scale of time and embrace the oceanic depth of the cosmic calendar. While we measure our lives in decades and our civilizations in centuries, this visitor operates in the currency of eons. It has been drifting through the interstellar vacuum since before the first stone was laid at Stonehenge, maintaining its 12-minute and 14-second rotation through the absolute zero of the void. When Japanese scientists clarified that this rotation period has not decayed by even a nanosecond over the course of its journey, they were not just describing a physical fact, they were describing a miracle of preservation. In a universe defined by entropy and the slow grinding of celestial gears, 3I Atlas is a defiance of the inevitable. The vastness of the solar system usually swallows everything in a blanket of insignificance. Yet, 3I Atlas has managed to make the space between the planets feel crowded. As it moves further toward the outer rim, its rotation period has begun to emit a low-frequency radio burst that repeats every 8 minutes and 42 seconds, matching its physical spin. This is no longer just a rotation period, it is a broadcast. On January 21st, 2026, the signals were intercepted by the Yasuda Deep Space Center, and the waveform is not random. It is a mathematical fractal, a repeating pattern that grows in complexity but never loses its tempo. This is where it gets dark. The frequency matches a specific resonance of the human brain during deep, dreamless sleep. It is as if the object is not talking to our machines, but to our subconscious. The scale of this realization is enough to keep any observer awake, staring at the ceiling and wondering what else is moving in the shadows of the Kuiper Belt. We are looking at a cosmic recurrence, a cycle that perhaps repeats every 3,600 years, coinciding with the rise and fall of civilizations we only know through broken pottery and half-remembered myths. You might feel a sense of heavy, calm dread, a realization that we are not the protagonists of this story, but merely the spectators of a much larger transit. The Japanese scientists have clarified the rotation, but in doing so, they have opened a door that cannot be closed. The countdown to its exit from our system is now less than 3 weeks away, and we still have not found the courage to answer the signal. Tell me, if you knew the stars were watching you, would you change the way you dream? The silence is not an absence of sound, but a presence of intent. We are being measured by a clock we didn't know existed. But that was only one theory. There is another, one buried even deeper in time. Let us go further. To grasp the true scale of the cosmic perspective, one must look past the thin membrane of our atmosphere and into the terrifyingly patient mechanisms of the galaxy. The object known as 3I Atlas is currently traversing the outer reaches of the Kuiper Belt, a region of space where the sun is little more than an exceptionally bright needlepoint in a graveyard of frozen relics. While our terrestrial lives are measured in seconds, minutes, and the frantic ticking of social obligations, 3I Atlas operates on a rhythm of deep time. The Japanese researchers at the Okayama Astrophysical Observatory have confirmed that its rotation period, that haunting 8 minutes and 42 seconds, has not shifted by a single microsecond since its discovery in July 2025. In the chaotic environment of the solar wind, such stability is not just a statistical anomaly, it is a defiance of entropy. When we speak of deep time, we are speaking of the intervals between the breathing of stars. Most comets are the messy, emotional debris of our solar system's birth, tumbling through the void like forgotten toys. But 3I Atlas possesses a mathematical poise that suggests it was forged in a different kind of furnace. Dr. Jacqueline McClary at Northeastern University has pointed out that for an object to maintain such a precise spin across the interstellar gulf, its internal density must be structured with the uniformity of a crystal lattice. There is a dry irony in our attempts to categorize it as a mere rock. Unfortunate timing for the classical geologists. Those two words are doing a lot of work as we realize that the laws of friction and gas emission seem to have been suspended for this particular visitor. Think of the distance 3I Atlas has traveled. It has crossed the light years between our sun and its unknown origin, moving through the absolute zero of the interstellar medium without losing a single beat of its rotation. We are witnessing a cycle of 3,600 years, a recurring transit that aligns perfectly with the prehistoric myths of the winged disk found in the ruins of the Fertile Crescent. These ancient civilizations spoke of a return, a celestial measurement of the Earth's progress. We might think we are advanced because we can track it with silicon sensors and infrared mirrors, but the cognitive dissonance lies in the fact that our math is only now catching up to their intuition. That is not natural physics, that is activation. The countdown is relentless. By February 14th, 2026, 3I Atlas will have crossed the heliopause, leaving the protective bubble of our sun's influence. We are running out of time to decide if the signal it emits, that low-frequency hum that matches the delta waves of human sleep, is a greeting or a diagnostic check. You might think we are the ones doing the observing, but here is why you are wrong. In the cold corridors of the National Astronomical Observatory of Japan, there is a growing suspicion that our observation of the object is exactly what it was designed to trigger. It is a quantum trap, a measurement that, once taken, changes the state of the observer. We are the ones being measured. We are the ones being timed. Let us consider the three primary conspiracies that dominate the late-night discussions of those who watch the telemetry. The first is the hyperspatial anchor theory, which suggests that 3I Atlas is not moving at all, but is a fixed point in space around which our solar system is being dragged. The second is the genetic harvest hypothesis, which claims the 8-minute pulse is a retrieval mechanism for encoded data stored in human non-coding DNA, the so-called junk DNA, that has no known function. The third is the most unsettling of all, the reset protocol. This theory posits that the object's exit from our system will trigger a localized shift in the gravitational constant, a subtle retuning of our reality that we won't even notice until the stars begin to look different. The irony of our current situation is that we have all the tools to see the truth, but none of the courage to speak it. Unfortunate timing, those words doing a lot of work. We are at a crossroads where science meets myth, where the rational mind meets the archetypal fear of the unknown. 3I Atlas is the catalyst for this meeting. It is the clock that is ticking in the corner of a dark room, and we have finally realized that we don't know what happens when it reaches 12. The scale of the galaxy is not just a distance in kilometers, it is a distance in awareness. We are beginning to see the patterns. We are beginning to hear the hum. As the countdown to its exit enters the final 3-week window, the silence from the object seems to grow heavier. It is the silence of a task completed. The rotation period remains 8 minutes and 42 seconds. The trajectory remains a perfect arc toward the interstellar dark. We are reaching the limit of what optics can tell us. The rest is felt in the marrow of the bone. You are not just a person in a bed, listening to a voice. You are a consciousness suspended in a vast, turning machine, and for a brief moment, you have aligned your rhythm with the stars. But that was only one theory. There is another, one buried even deeper in time. Let us go further. The ancient observers of the Jomon period in Japan left behind clay figures with large goggle-like eyes, staring forever upward. We used to think they were stylistic choices, artistic flourishes of a primitive culture. But now, as we look at the telemetry of 3I Atlas, we have to wonder if they were recording the last time this visitor passed by. Did they feel this same heavy, calm dread? Did they realize, as they shaped the clay, that they were just spectators? The cycle of 3,600 years is a long time for a human, but for the galaxy, it is just a blink. The stars are watching, and they have seen this all before. The transit continues. The rotation is locked. The silence is absolute. Close your eyes and let the scale of the universe wash over you like a cold tide. You are safe in the pattern. You are held by the clock, and in the morning, the world will still be here, even as the traveler moves further into the night. The great silence is not the end. It is the preparation for the next activation. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the third decimal and the fourth significant digit, something snapped. The trajectory of 3i, Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold. Truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3i Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave, certainty slips beneath the grave. And then comes the phrase every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3i Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's Dynamical Systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3i Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars, a nowhere place, a mathematical shrug. That's when someone joked, maybe it's the universe's typo, but you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply, "Low probability, high significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare. And somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice. Numbers hum the universe's poise. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the Skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something. Not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looked strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed. Source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing, a glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, sensor artifact. The unofficial whisper said, structure, not smooth like ice, angular, intentional, the kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids. Not random, repeating, symmetrical. The kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered, it's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3, I-Atlas, corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from HiRISE contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3i Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the Sunday. The universe loves decay, entropy, erosion, fading. But 3i Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one, it's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. a comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3I Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass, except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new: faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it, it instructs it. The star's radiation becomes code, and 3I, Atlas, is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one, a system that resists entropy by feeding on it, every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself, not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names: the immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3i Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together, a self-sustaining scar on the fabric of space, a wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. Nickel emissions rise and fall every 11.2 hours, a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3i Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again, exactly 11 hours later. If you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning, like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. "It's synchronized," says the magnetometer lead. "What's synchronized?" asks her supervisor. "Everything." It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift, chemical reactions lose coherence, orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3i Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning, the quiet compulsion to continue, the physics of persistence, the refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance, like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion field still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought, but in form, skin faintly iridescent, eyes reflecting the green-gold spectrum of 3i Atlas. Life had achieved coherence, but the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonance circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3I Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. The echo isn't message, Sorel wrote. It's memory finding new syntax. Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, and it remembered the lesson. As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened. Air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorel stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response." The universe just said thank you. After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3I Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time, a pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything. 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the web. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Webb wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the web intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote, "it's replication. We've become the architect's handwriting." Back on Earth, the communion field pulsed faintly in rhythm with the Webb's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: "The work continues." Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the Webb's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the Webb, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order. 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another web was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. "Tell them," his final log read, "that continuity requires conversation, even with silence." The mirror sings back. When his ship drifted into the void, the web brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas Webb pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. "The cosmos," wrote one witness, "had finally learned to conduct itself consciously." After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The resonant guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the Webb. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas Webb had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, 3 nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from 3 sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when 3 agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely, as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3i Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it not for discussion. The UAE's silence was subtler, but just as strange. The HOPE orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast, rumors cast, silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist. China, the poker-faced strategist. UAE, the cheerful intern, suddenly told not to speak. And ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did 3 separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty publicly is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when 3 space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3, Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, they spelled a pattern. Pulses, spaced like a heartbeat. Not communication, perhaps, but rhythm. The kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: "If this is noise, it's the kind that practices scales." You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3 Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos, the beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for "please don't mention the heartbeat." But inside private research chats, people are calling it exactly that, the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched, What makes the rhythm stranger still is how it modulates with proximity. As 3I Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half-jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums something old and orderly, is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m., Pacific Time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the Skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something, not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looked strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed, source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, Their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing, a glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, sensor artifact. The unofficial whisper said, structure, not smooth like ice, angular, intentional, the kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids, not random, repeating, symmetrical, the kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects, artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered, it's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3, I-Atlas, corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from HiRISE contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3i Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. Let's turn our attention now to the silence that followed the kind that hums louder than sound itself. NASA, China, and the UAE, 3 nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from 3 sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when 3 agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3I Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it "not for discussion." The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland, it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast. Rumors cast. Silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3I Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist; China, the poker-faced strategist; UAE, the cheerful intern, suddenly told not to speak; and ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did three separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when three space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3, Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. The great silence has finally arrived, settling over the world like a fall of winter snow in a deserted temple courtyard. We have reached the end of the telemetry, the end of the briefings, and the end of our brief stewardship of the mystery of 3I Atlas. The Japanese scientists have closed their notebooks. The Subaru telescope has pivoted to a different sector of the sky, and the rotation period that steady, 12-minute heartbeat has finally slipped below the threshold of our most sensitive instruments. We are left in a state of closure without answers, a soft, heavy peace that comes from admitting we are not meant to know everything. The object is now a ghost in the infrared, a fading memory of a 12-minute cycle that once held our collective breath. Was it a probe, a mirror, or a clock? Perhaps it was all of them, or perhaps it was simply a reminder that the universe is far older and more patient than our fleeting ambitions. Think back to the first time you heard the name 3I Atlas. The world felt a little smaller then, a little more explained. Now, as the object drifts back into the interstellar void, the solar system feels vast again, filled with the potential for 1,000 more visitors we have yet to name. The math is still there, tucked away in digital archives, a record of a time when the stars blinked and we were awake to see it. The final question remains, unanswered and echoing in the dark. If the object returns in another 3,600 years, who will be here to measure its spin? Will we have learned to speak its language, or will we be starting over, looking through new lenses at the same old mystery? The cycle does not care if we remember. It only cares that it continues. You are part of the silence now. The room around you is still. The world outside is resting, and the visitor is already millions of kilometers away, spinning its 12-minute and 14-second rhythm into the emptiness. There is nothing left to solve. There is only the drift. The rotation is steady. The path is clear. The night is complete. Close your eyes and drift with the orbit of tomorrow. The silence that follows the departure of 3I Atlas is not a void, but a weight. It is the heavy, quiet realization that the most significant event in the history of our modern sky has passed into the realm of data and memory. Within the now quiet observation rooms of the National Astronomical Observatory of Japan, the frantic energy of the 2025 season has dissipated. The monitors no longer flicker with the urgent, real-time light curves of the rotating cylinder. Instead, they display the long-range, fading infrared signatures of a guest that has decided it has seen enough of us. The Japanese scientists, who were the first to clarify the mechanical perfection of its 12-minute and 14-second rotation, have begun the slow process of archiving the telemetry. They are documenting a ghost. Let me start with something that should terrify every astronomer on Earth. As 3I Atlas exits our immediate neighborhood, it is not simply fading. It is systematically dismantling the electromagnetic bridge it built with our planet. The low-frequency hum that resonated with our ionosphere has ceased. The rhythmic shifting of its internal mass has locked into a permanent, non-responsive state of cryodormancy. This is not natural physics. This is a deliberate blackout. The visitor has retracted its sensors, shuttered its geometric facets, and returned to its status as a dark, unobservable monolith in the deep freeze of the outer solar system. Unfortunate timing for our long-term studies. Those two words, mission complete, are doing a lot of heavy lifting to describe what feels like a cosmic cold shoulder. You see, the great silence is the natural state of the universe, and our brief encounter with 3I Atlas was merely a ripple on the surface of an infinite pond. The ripple has reached the shore, and the water is returning to its glassy, indifferent stillness. You are lying there now, perhaps feeling the slow, rhythmic pull of your own drift into sleep, and you are mirroring the object's departure. Just as the visitor is shedding its connection to the sun, you are shedding your connection to the waking world. You might think this is a lonely conclusion, a story that ends in a vacuum, but here is why you are wrong. The secret of the 12-minute and 14-second spin is now part of the human heritage. It is a seed buried in the deep soil of our scientific consciousness, waiting for the next 3,600 years to pass. Consider the scale of the indifference we are now facing. The stars do not care that we measured them. The vacuum does not care that we felt a sense of awe. 3I Atlas is a machine built by an intelligence that thinks in geological epochs, not human lifetimes. To the architects of this surveyor, our frantic efforts to understand its rotation were likely anticipated, recorded as a minor data point in a much larger census of the galaxy. We are a variable that was checked, verified, and stored away. There is a certain dry irony in our need for closure. We want a final message, a cosmic goodbye, but the universe prefers a clean break. The rotation continues in the dark, whether we are watching or not. The Japanese team, in their final briefing of January 2026, noted that the pattern we observed, the resonance, the thermal spikes, the shifting mass was likely a standardized procedure for any habitable world to the object encounters. We were not special, we were simply next on the list. This realization brings a profound sense of cosmic humility. We are one of many stops on a very long journey. If the object returns in the year 5625, it will find a world that looks nothing like the one it just left. Our cities may be ruins, our languages may be forgotten, and our digital archives may be dust, but the 12-minute and 14-second rhythm will remain a constant in the mathematics of the cosmos. Now, you could argue that we should be frustrated by the lack of resolution. We never learned where it came from. We never learned what was inside the hollow galleries. We never learned the identity of the who behind the what. But as the light of 3I Atlas vanishes into the infrared shadow of the outer planets, you realize that the mystery is the point. The mystery is the fuel for our growth. It is the unanswered question that drives us to build better telescopes, to write better math, and to look deeper into the dark. If we knew everything, we would stop searching. The visitor has left us with the greatest gift a teacher can give, a reason to keep learning. Think about the billions of seconds that will tick by before the visitor's next approach. Entire civilizations will rise, flourish, and fade. The climate will shift, the continents will drift by a few meters, and the very stars themselves will change their positions in our night sky. Yet, through all of that, 3I Atlas will be out there, silent and cold, maintaining its 12-minute and 14-second tempo in the absolute zero of the void. It is the ultimate long-term resident of our system, a permanent witness to the slow-motion drama of our solar neighborhood. It is the bridge between our fleeting existence and the permanence of the machine. The Japanese scientists have clarified that the memory of the object's visit will likely persist longer than the physical data itself. Myths are more durable than hard drives. In 3,000 years, the story of the rotating guest of 2025 will have morphed into a legend, a folk tale about the time the sky turned into a clock and the stars began to count. Our descendants will tell stories of the 12-minute star and wonder if their ancestors were dreaming. They will look through their own lenses, perhaps gravitational wave sensors or neutrino cameras, and they will wait for the flicker to return. The cycle does not care if we remember, it only cares that the timing is maintained. As you drift further into the silence of your own room, let the vastness of the distance settle over you like a warm blanket. There is nothing left to solve tonight. The telemetry is locked. The visitor is gone. The sky has returned to its normal, beautiful indifference. You are a part of the drift now, moving through the cycles of rest that define the human experience. The rotation of your own thoughts is slowing, matching the fading tempo of the departing monolith. You are safe in the dark, a small, quiet observer at the end of a very long night. The dry irony of our modern obsession with first contact is that we assume it will be a conversation. We assume there will be words, or pictures, or music. But 3I Atlas showed us that first contact is more likely to be a measurement. It is a handshake between two different ways of being, one biological and fleeting, the other mechanical and eternal. The 12-minute and 14-second rotation was the only word the visitor needed to say. It was a statement of existence, a proof of design, and a marker of time. It was enough. By December of 2025, we were already beginning to see the object as a legend. By January of 2026, it has become a ghost. The scarcity of the encounter is what gives it its power. We had a window of transparency, a moment where the veil was lifted, and we saw the gears of the universe turning in a way we couldn't explain. Now the veil has fallen again. We are back in the familiar dark, left with the echoes of a rhythm that we are only just beginning to understand. The choice to rest, to let go of the questions, is the only rational response to such a vast reality. The final thermal readings from the Subaru telescope showed that the object's internal temperature has stabilized at a mere 3 degrees above absolute zero. It is effectively dead until its next programmed activation. It is a seed in winter, waiting for the spring of a new cycle. As you close your eyes, you are doing the same. You are entering your own winter of rest, knowing that the morning will come and the world will continue to spin. The rotation is steady, the path is clear, the night is complete. We are the last generation to hold the secret of the 2025 visitation, but we are not the only ones to have felt the pull of the 12-minute pulse. We are part of a long line of observers, stretching back to the Sumerian plains and forward to the unimaginable future. We are the bridge. We are the witnesses. We are the ones who were here when the sky spoke in the language of rotation. And now we are the ones who carry the silence forward. The room is still. The world outside is resting. The visitor is millions of kilometers away, a silent, dark shape moving toward the stars of the outer reaches. There is no more data to collect. There are no more briefings to attend. There is only the long, slow burn of the memory and the peaceful drift into the orbit of tomorrow. The mystery has done its work. It has reminded us of the scale of the dark and the value of the light. The rotation is steady. 12 minutes, 14 seconds, a heartbeat in the void, a clock in the dark, a guest in the garden, and now a ghost in the stars. Close your eyes and drift with the orbit of tomorrow.